Hey, thanks very much for the introduction. I'm really happy to be here today at Nodes. It's one of the most fun times that we get to do each year with the Neo4j community. Get to talk about more development and technically oriented concepts. And today I'm going to take you through a really rapid 10-minute example of how you can get data from any kind of a data warehouse into Neo4j using our supported connector for Apache Spark. So briefly at the top here, I am operating in a Databricks environment for this particular demonstration. And this picture here is showing you what we are going to be doing today in the next 10 minutes. So the way that we combine Neo4j and Spark is we can take data out of any source in a table format, and then we use this mapping structure that we call tables for labels. Tables for labels is really simple. We just decompose any kind of source data that we have into a set of node tables that correspond to the different labels in our graph, and any kind of links inside into a set of relationship tables that go from and to. And so in this way, we can think about taking any big complicated table and basically normalizing it to the point where you can write a graph structure out of it. Now, to do this, what we're going to do is we're going to take data from journal Nature papers. So in my particular case, I'm taking this out of my Hive database, but I loaded that data from BigQuery. And so BigQuery over here has a publicly available data set of every single journal paper ever published as part of the journal Nature. And it'll tell you when the paper came in. You'll see that there is a delimited list of authors for each paper, a set of categories, a body to the paper, and so on. Over here inside of Spark, I've loaded that into a Hive table, and you can see that I've got 125,000 papers, and you can see roughly what that data looks like in a Spark data frame. So, but this is this very wide, dense table. How are we going to get this into the graph shape? Well, the first thing I'm going to do is I'm going to define just two simple Python helper functions. The first function is going to be called explode nested field. And so basically, like if I have a field inside of my data that is delimited by a semicolon and a space, the separator right here, what I'm going to do is I'm going to explode that field, and then I'm going to alias it by a given particular name, and then filter where that field is not empty. And so in this way, I can basically recreate relationship tables. And I can say, well, this paper ID is attached to this author, and end up with a bunch of pairwise records like that. The second little helper function I'm going to define for myself is to write a data frame with a Cypher query to Neo4j. So what I'm going to do is give it some parameters saying, where is my database located at? What batch size do I want to operate with? What's my username and password? And then what the query is and so forth. So that's just all set up. Now let's just kind of get into it. What I'm going to do is take papers as my first node label. And I'm going to run this SQL query right here, and that'll tell you which fields about a paper I'm going to put into the paper node, the ID, the title, the abstract, and so forth. And so I'm going to simply create that data frame and then write to Neo4j as a data source, overwriting anything that I find. And I want to save every single row in that data frame as a paper object in my database, identified by the ID field. You save that, you run this paragraph inside of Databricks, and a few seconds later, all of that data is saved to Neo4j. So that just gave us like this anchor node paper. So let's expand out from there and say, basically what we want to do is explode a nested field, that is that delimited set of authors, and get to a data frame that looks like this here below. So you have the ID of the paper, you have the author, and then you have their index. So for academic papers, it matters whether you were mentioned first or second or third. So we're going to keep that index because we're going to store that as a relationship property next. So now that we've got that author's data frame reshaped from our original table, this is how we might write that into Neo4j. So we're going to take a query, and we're going to explode the nested field and then write with this query. So what is this query here doing? So we know that every single time we get a line in on the data frame, we're going to get a paper ID. So we're just going to go ahead and match that paper because we wrote it in a previous step. Then we're going to merge the author with whatever the name is of that author. And then we're going to merge a relationship between the paper and the author. And we're going to put an index property on that to indicate whether this person was first or second or third author and so forth. So that gives us papers connected to authors. Then we're going to go a little bit further and we're going to do the exact same thing with a different nested field, namely organizations affiliated. And so, for example, a research institution might have 5 PhDs that work for that research institution that all collaborated on a paper. So now what we're going to do is we're going to do the same kind of general technique and we're going to create papers affiliated with organizations and so forth. And so once we run each of those code blocks, basically Spark is going to handle all of the parallelism and the batching for us because that's just a feature that comes with the connector for Apache Spark. And what you end up with is a graph that looks like this. So over here, I've got my Neo4j instance. Let's just pull up some papers. And let's see. Here we've got a paper called Identification of Antigens Presented by MHC for Vaccines, etc. We can double click on that and then blow it out into a set of authors and a set of affiliated organizations. We could then, if we wanted to, click on that organization and find what other papers that organization had presented and so forth. And so what we've done so far is basically take a big nested structure like this, where you have this wide denormalized relational table, and we've iteratively cut it down into a series of tables that look more like this, where you have one table per node type, and then relationships between them, where we write an anchor node first, and then for each kind of extra relationship hung off of that node, what we do is iteratively factor that out of the base table and write both the relationship and the incident node. Now, I want to show you a couple of other quick things about this. There are two critical performance controls when you go to do this with your data coming from any warehouse. So first, on the warehouse front, as you probably know if you've used the Spark environment before, you can either use JDBC connectors or you can use the stuff that's built into your Spark environment to query most data warehouses. So whether it's BigQuery, whether it's Oracle, Teradata, Snowflake, doesn't really matter. Getting all of that data into the Spark environment should be straightforward. And then once it's in Spark inside of this data frame, you can get it further to Neo4j. Some critical things to point out here are the batch size. Okay, so when you write data to Neo4j using Spark, what we're really doing is the equivalent of a query that looks like this: unwind batch as event. And you'll notice that in my queries down here, for example, I refer to a variable called event. That's going to be bound automatically for you by the Spark connector. But to control the memory utilization of this process, you need to set, for example, a batch size. So this means that we're going to be writing papers to the database in batches of 1,000 at a time in this particular instance. Whereas with smaller nodes like authors and organizations, I think I was writing them in batches of 50,000 at a time. Yeah, it's right there. So the other issue is parallelism. And this is one that's very important to understand and to control for in these environments. So when you execute an operation on Spark, you're typically farming an operation out over a cluster of machines. That means that when you're writing data to Neo4j, it's not just a batch at a time, but it might be potentially 3 or 4 batches running in parallel. And the way that we control that parallelism is by repartitioning the data frame. And so you'll see right here, I did this .repartition1. That's actually very important because what I did is I forced Spark to gather all the data up into one partition so that I would be running batches of 50,000 at a time sequentially. Now, these performance parameters are very important because you need to respect whatever the memory limitations and the configuration of your particular server is. Additionally, you can get better throughput sometimes by using fewer partitions and larger batch sizes. So you have a lot of control on how quickly the data gets in using some of these settings. So we're getting here to the end. Got about 1 minute left. I just want to leave you with this. If you go to neo4j.com/developer/Spark, you're going to find all of the documentation for doing this sort of thing. You go to writing to Neo4j, and it's going to give you complete documentation about how to do these things in both Spark and Python. And we're seeing a lot of uptake within customers who are using this to engineer data from data warehouses into a graph environment, and then mixing and matching cool techniques like the use of graph data science to compute novel graph metrics over their data. Once you've actually used GDS to compute graph metrics, you can also use this same Spark process to go the other way and to pull data from Neo4j back into any other technology that you might be using, like, for example, a machine learning as a service platform. And that is about it. I appreciate you guys taking the time for this rapid tour.